Yeah, hi, my name is Jim Marson. I'm here today to talk about an ether concept that is called, I'm calling it the Tron theory. I know that the name is not but I know the name isn't that good in some ways, but because other people use it. There are movies out now. But I decided to keep the name as it is because the idea of a very simple name is meant to go with the concept of the particle that makes up, in this theory, the ether. Okay, so we're going to try to. I mean, people have talked about an ether, but what is it made of? Okay. So the Tron is this. Can you go down to the first diagram? Is generally a spherical particle that fills up all of space. Three-dimensional. It's a real particle. Has minute mass. It's much smaller than an electron. And as you can see, it's in turn made of even smaller particles with this very similar with the same structure. Okay, and these smaller particles we call Rons, which is one less letter than Trons. Some people, and you can see that they emanate out from a central core in a radial manner, where the number of them in any particular shell is constant. So the density of the matter decreases as you get farther away from the center. And of course, as some people have talked about wanting to have an infinite chain of particles, that every particle is made of another particle, then we have the Rons are made of a smaller particle called Ons. Okay, and then it goes on and on. All the same structure, all the same laws of matter. Excuse me, the same interaction properties. The most fundamental property is that a Tron wants to grow, wants to get bigger by accumulating Rons from other Trons. And this is the force that causes the Trons to cohere in space, because they're contiguous. They're not like flying around. They're basically in place, filling up space, and the space between them is filled with Rons. Space between the Rons is filled up with Ons. So it's complete. In that sense, it's a continuum, but with structure. So this tendency to grow is what leads to electric fields, magnetic fields, gravitational fields. Another aspect is that if you compress Trons enough, they form stable particles themselves, larger particles, electrons. Compress a bunch of electrons together, you get nucleons. You have to leave out the concept of charge right now. In other words, Trons also are what make up matter. So, there are a lot of objections to the whole concept of ether. The most fundamental one was, of course, the Maxwell experiment, where they expected to find the velocity of the Earth as it revolved around the sun. Sorry, I'm a little nervous.
No problem.
So,
could you put your microphone kind of keep it fairly close to
Yeah, close to your mouth.
yeah, okay.
Put it on your chin. No, it works. It works.
Okay.
It works.
So, the obvious answer to the null results of interferometer experiments done at the surface of the Earth is that the Earth entrains the ether. Okay, that's what Michelson himself believed till he died, I believe. But the theories of the ether back at the turn of the century all involved incompressible fluids, whereas this is compressible. It has variable density. The more trons in a given volume of space, the higher the potential. The higher the gravitational potential, the higher the electric potential. And the gradient, or the variance of the density from one place to another, is what the electric field is, or the gravitational field is. So the fact that it's compressible, according to Planck, and there was a paper that Planck wrote, that compressible fluids could have, a compressible ether, I should say, could have a zero velocity at the surface of the Earth, the entrained ether. Okay, but it's not entrained forever. It's not absolute. A lot of ether theories say there's one absolute ether that has everything moves against. Here we're saying that ether is carried with a large mass, okay? There's a gravitational field around it. It's like an atmosphere, but it's not an atmosphere in the sense of gaseous, where all the particles are flying around independently. I'm sorry, I'm so nervous.
Just relax, relax. You're
I'm
okay.
trying.
That's all right. Put it up here.
Yeah.
Just relax. We're all your friends.
Okay.
Are you on this diagram still?
You can go to the next one.
Okay. Sounds good.
Pretty big.
This one?
Yeah, that's good.
Oh, I see.
Okay.
That's the diagram.
So this is an illustration of the idea that trons are compressible. That if you have, say, larger trons in a lower potential area, and somehow you compress them, you would sort of squeeze out the rons that they're made of, and they become more dense. Okay, higher mass. And the difference between the density there and the density there, if you have a continuum of change of density, gradient, that's when you have an electric field. And I think the gravitational field is actually the same idea, but at the Ron level, because it's much weaker. So once you've come up with an ether that is compressible and carried with a massive body, then you don't need the second postulate anymore. And you can conceive of maybe taking an interferometer out into interplanetary space and trying it out there. That's been proposed before, but since ether concepts are so out of the mainstream, nobody with enough money has ever considered actually trying it. So, okay, we can go to the next one, I guess. Any questions so far? Am I making any sense to anybody?
So you said that you have an assumption of on the compressibility of the ether. How about the viscosity?
We're not talking about fluids here. This intertron force of wanting to grow, and each tron around it is trying to grow, and they're cohering to each other.
The compressibility is there, but do you need the viscosity for
Well, I wouldn't call it viscosity. Because that's too close to fluid dynamics. You've got to get away from the idea of pure fluid dynamics.
I mean gas, more gas.
And that's how you can get transverse waves. Whereas, if you're just talking about a fluid, you can't have transverse waves. But this tendency to grow, and they fight with each other, leads to the ability to, when a field is formed, field, meaning a gradient of Trons, that can be a field that instantaneously transfers to the wavefront. So this is the illustration of the Tron force interacting with other Trons. Okay, you can see that the Trons in the center are denser. They want to grow. They want to take Rons from the outer, less dense Trons. Okay, and that's what happens. And then you get, so the ones in the middle get larger, and the ones outside of this diagram get smaller. And there's this overshoot, this harmonic overshoot, which leads to the next picture. Next
Is this the right one? Oh, no, you know what the next one?
Yeah.
No problem. Do you know what side of the pages is it further down?
It was, I think it was right next to it, right under the other.
It would be over on this other side? I'm sorry, I'm working in the... No problem. This one?
Yeah, okay.
Okay, hold on, let me get down a little bit.
And I've drawn these for simplicity, and because my software wasn't all that great as circles, but they're not purely spheres actually. These are representing three-dimensional objects. Okay. But the actual dimensions of a Tron are defined by where the largest Tron from the center or of the Tron starts to become less as it crosses into the boundary of the adjacent Tron. So you can have different shapes effectively, like a capacitor. 2 plates of a capacitor will not necessarily be. They might be more like well, not circular, not spherical. They would conform to this gradient of larger Trons, negative low potential, to more dense Trons, high potential. And this is what leads to the attraction, the electromotive force. Okay. So you can see here where the Trons in the center have grown. They've sucked off the Rons from the outside. And now the ones on the outside are smaller, and they start to suck the Rons back. And then you have this pulsating phenomenon, which actually leads to the phenomenon of quantum mechanics. The idea here is that other microparticles, like electrons, have this pulsating activity where they suck Trons onto them, and then they get fatter. I hate to use these words because they're so...
No worries. It's much better than mainstream's words. So.
Well, it's not an exact definition. You know, think of the idea of just getting bigger and lower potential, and then they grow to a maximum size relative to the Tronos around them. Instead of calling it ether, we like to call it a Tronos, since it's not exactly what other people have considered ethers, but and this pulsating motion of, say, electrons leads them to have a non-constant velocity. If you shoot an electron out of an electron gun, you have an average velocity that we measure, but as these Trons are pulsating down their path, their velocity is pulsating, harmonically changing, shifting, faster, slower, around the medium, the average. And that's what a matter wave is. That's what de Broglie waves are. And that's what leads to quantum mechanics. That's the wave nature of a particle. Talking about duality yesterday. That's what I consider to be the wave nature of a particle. And by the way, I also think that electromagnetic waves are just waves in this Tronos. There's no particle that you call a photon that magically jumps to speed of light when it's emitted. So the concept there is that this matter wave, this book that I started talking about at the beginning, Einstein plus 2 by Peter Beckman, imagines or actually derives the Schrödinger wave equation from exactly this idea of a matter wave being an oscillation of the velocity, a perturbation of the velocity of a microparticle.
Did you want to take some questions?
How are we doing?
We're doing okay. You got some more?
Well, I'd also like to talk a little about the concept of fusion.
Okay.
We have Einstein's idea that matter is destroyed and becomes energy. It's a very nebulous concept, right? What does that mean? Well, with the Tron theory, you have two particles that fuse, two protons that fuse. When they come together, they squeeze out trons that they're made of at the interface, and those trons become part of the ether, the Tronos. Okay. So no matter is lost. It's just when the trons are released by the fusion reaction to become part of the Tronos, they increase the density of the Tronos, the potential of it, the energy of it, the potential energy of it. So that's my interpretation of E equals mc squared. Another thought that the trons being having matter, having a variable matter around variable density, around a large body like the sun, the speed of light through that medium is going to vary with the density of the trons. That's how you get starlight bending. That's how you get the GPS change of clock change as you launch it in space, because the speed of light is slower farther from the Earth's surface, and that affects the clock in the GPS satellite. What do you think of that idea? So, and I guess one more point. Well, I mean, there's a lot more points, really, but one I can think of at the moment. If this matter, which the density drops with the gravitational potential as you get farther away from a mass, the potential drops, the density drops, is 1 over r. And that is the same relationship that galaxy rotation has been defined as in terms of affecting the revolution speed of stars at the edges of galaxies. So I'm proposing that this Tronos is dark matter. And the reason you can't detect it, when you're looking for particles, you can't see it, it's because it's the medium that transmits light. It's not a separate particle itself. So how are we doing now?
I think is that your last diagram? I think it is.
Yeah, I think so.
we're okay. I mean, let us know when you're ready, if you want to take some questions.
Well, you can
and
take some
open up-
questions now.
and open
If
the
there's any
discussion.
ideas that come up, any thoughts, I'm sorry I'm not better prepared for this.
No problem. Okay.
So as you were talking, I made some notes here. It's interesting how you got to this at the end, but I wrote down here that a dense Tron field could be responsible for the slowing of clocks in the gravitational field, the Shapiro time delay for a solar grazing array, and of course lensing around massive objects. And then you came back to that. So I thought that was very good. You mentioned the speed of light is slower away from Earth. Actually, the speed of light is going to be faster.
I meant, no, it's slower through a denser Tron.
Exactly. And
Right.
so I thought, anybody who knows me, I have no need of an ether. Like Einstein, I have no need for that concept. But of the ether theories I've seen, this is very consistent and hangs together well. I really like what you've done here. I'd like to see you flesh this out some more. One of the things you mentioned, though, was taking an interferometer into space, Michael's Moreland experiment. What would you expect to get different in space than
Well, if you can
than
get
on
out
Earth?
past where the ether is entrained by the Earth,
Mhm.
the Earth's ether, I should say. I mean, the sun has its own ether. Well, the Tronos of the sun is a separate thing. So then you would be traveling within the sun's Tronos, and you would expect to see this phase shift. You might have to go like at least 1 million miles from the surface of the Earth, because that's where the outer boundary of Earth's Trons.
Okay, so you're saying
Switch
you
over.
get a fringe shift due to the galactic.
No,
motion.
due to the solar. But you have to get away from where it's held up. I mean, you have to get away from the surface of the
Like
Earth,
the Lagrange point, maybe.
or even just
Yeah.
interplanetary space. Just
Okay.
send it into orbit like you're going to Mars or something. Yeah.
But wouldn't the Michelson-Morley apparatus itself have its own entrained?
We were saying we're talking about masses the size of the Earth before we start to get real entrainment. I mean, maybe there's entrainment down inside the steel, but
But not around it.
right.
Huh.
Answering that question, when people try to put numbers to it, it's usually that the entrainment is related to the gravitational field, so.
Well, potential.
Potential.
The field is actually the gradient of
Yeah.
the potential. So
Right.
we have, there's been a discussion about is potential a real thing. I'm saying it is.
Yeah.
Another possible experiment might even be to try to set up a very high voltage, constant voltage inside a cylinder, and see if that affects the speed of light. I don't know how, I don't have numbers to know whether it's something that you could do practically. It might take 10 million volts or something like that. But yeah.
Maybe one more thing, just in continuation of my previous comment or question
Okay.
regarding the viscosity. Actually, viscosity should be important for very structuring of those objects that you are taking as given. And the other thing.
One point here is that the viscosity might not be a constant value that's always there, like with a fluid. It might, in a sense, be instantaneously set up when a field forms. The gradient of a field forms.
Yeah, okay, maybe those very elements which constitute.
But it would always be similar to the concept
But I would
of
say
viscosity.
this, I mean, if there is no something like that, then still Tesla should have been right when he claimed that there is no way in the ether as ideal substrate without viscosity for the transversal waves to exist because of lack of the
Yeah, I'm sorry, I'm not following you.
steering and so on and so on. I mean, so that's sorry, the reason that I could kind of insisting with this aspect. Because actually all the scientific community started hating him because of this just common reason. I mean, some reason, common sense.
Right. But you would probably say that there's no friction in your theory between the molecules, and that's a problem trying to figure out what the viscosity is if there's no friction.
Well, like I said, when a field forms, when you get a gradient of density, that in effect might be an instantaneous kind of pseudo viscosity because you know, the Trons are cohering more strongly.
Right, but I want to answer his viscosity thing, because in my other theory of the ether, when you have a lot of elements, right, working together, flowing, rather than friction, what happens is you have the ratio of the elasticity constant and the inertia. The ratio of elastic, right, you have a spring and you can squeeze it, but it's got inertia. So if you take a spring and squeeze it together and let it go, it vibrates all on its own with no
Yes,
friction.
but if we go a step below, you know, to see where that inertia comes from, what it is, you know, how the structuring can come into place at the first place, how to say, you know. Then actually we have to think kind of, like, say, viscosity. And on the level, on those maybe elementary gyrons or tachyons or whatever who are spinning as gyroscopes, then the very precession effect can be considered as a viscosity.
Yeah, see, I'm supporting you, right? I'm supporting you, and I'm saying.
I guess okay, but thank you. But I just wanted to really just somehow we are kind of physics, particularly modern physics. We are thinking in numbers, and you know, something. Everything is ideal. Everything is like, you know, something interacting with some other particles and so on. I mean, in my way, I mean, I was pretty much hating when I was reading the Asikoski heterodynamic, you know, because everything was going down to the pressure, gradient of pressure, gradient of density, gradient of velocity, you know.
Yeah, we kind of have to think outside the box here. We just stick with straight fluid dynamics. We're not going to get anywhere.
Who are maybe engineers, something pretty much was not fond of, you know. But unfortunately, it looks that everything has to be brought back to those very basic concepts.
Right, but I'm supporting his idea too, and I think another way to look at this is that we don't have to know atomic physics to deal with molecular physics. We can just work with chemistry and so forth and get a lot of results without knowing the physics. Now, it'd be fun to know the physics later on and go down, but we can understand his principle just at the magnitude it's at.
Okay,
Right, see, and then we can go deeper later on.
Yeah, because it's important. I see many things that I kind of, okay, if I will consider, sound.
Well, before we can get rid of relativity, we got to come up with an alternative. We can prove it's wrong until we're blue in the face, but unless we've got an alternative that works, this is an attempt to define an alternative.
One more question back here?
Well, it's more of a comment.
Comment?
There was a fellow who invented the Reynolds number called Osborne-Reynolds, and his last work was around 1900, in which he attempts to model space as billions and billions of spheres in space. I think he makes one mistake, and that is, I think his spheres, he wants them all about equal in size, which I think is perhaps a mistake. I think that Huygens also attempted to model space as filled with spheres, and the light, so that he could get his waves. The last comment, perhaps, is that the Reynolds number employs certain, it actually employs the unit of viscosity, and viscosity per volume does have the dimensions of angular momentum, I think.
But you're talking about molecules.
Yeah,
I'm talking about
I'm
atoms
talking about a layer much lower than that, where we have to you have to think outside the box. I mean, we just think of fluid dynamics principles and try to apply it to the ether, we're going to lose.